Hi, Nancy. You have this a bunch of these proto boards, and they come in a box. And in the box, wrapped in this anti-static wrap, there's this plug with pins in the bottom. There's a black foam cushion you have to remove in order to expose these pins. And you know, these pins are supposed to go onto the proto board. So there are these holes here. Now, these holes are for sticking electronic components and wires into, and underneath all these holes that I'm pointing to here, there is a continuous aluminum strip underneath this plastic. So all these holes are connected by one continuous wire. So if you plug something into, let's say, that hole, electricity will flow freely between that hole and something plugged into this hole and that hole and that hole, and it goes from here all the way to here up to the middle screw. You see there's a screw in the middle, and that same thing is true for these holes, right? That same thing is true for these holes up here. That same thing is true for these holes up here. And then separately, there's a separate wire underneath here, or aluminum kind of runner underneath for these guys, okay, and these guys. But it is not the case that these guys here, these holes here, are connected to these holes here. Those guys are not connected. So this board is kind of divided into two halves, like and the line of demarcation is given by these screws over here. So there's this half, and there's the other half, this half, okay? Now, here's the idea. This plug, you plug it into just these side rails here, these side holes here. Let me get that in there, okay? Now you can push it down as far as it'll go, okay? So that the pins that were on the bottom of this green board actually go as far as possible into these little holes, okay? Now that does something. That makes these pins here, these pins on this green board that say +5, these +5 pins, these pins are now connected to all of these holes. And it doesn't matter which hole you plug some component into or some wire into, that hole will have positive 5 volts, okay? And that's positive 5 volts compared to the ground. And the ground is right here. These pins give you the ground, and they're connected to these holes up here, this line of holes. So anything you plug into these holes up here, they will be connected to the ground, right? And the same thing is true over here. There's positive 12 volts on any of these holes, and then there's negative 12 volts on any of those holes. So if you put something in this hole and you put its opposite leg into that hole, you will get 24 volts because it's a positive 12, negative 12, right? If you just want 12 volts, you put something, you put one end of your component into that hole and the other end into one of these ground holes, and then you'll get positive 12, right? So that's how that works. What if you wanted 17 volts? If you wanted 17 volts, you would put one wire from your component, be it electric motor or speaker or light bulb or whatever you want, you know, one wire into this positive 5 hole and another wire into this negative 12 hole. You'll get 17, right? So I know what you're thinking. You're thinking, what do you mean? Where is this voltage coming from? It's coming from this plug, and it's not here yet. You plug the power supply in here, okay? So this is the power supply, and it gives you 5, 12, or negative 12 volts. And here's its plug, and that plug goes right in there. All right, there it goes. All right, there we are. Now, once I plug this, it has its own wall power plug. Once I plug that in, where is it? Okay, here it is. Once I plug that into the wall, I have plugged it into the wall. Now this board is hot, meaning it is powered. So, are all the holes powered? No. Remember, only these holes have the 5 volts. These holes have nothing. These holes are connected to the ground. These holes are connected to just each other. These holes positive 12, these holes negative 12, these holes nothing, and these holes nothing. Okay. So these holes are These holes are very, very useful, and that's because they are connected to each other in the following way. Let me get a little wire here. They are connected to each other in columns. So these 5 holes, these are all connected to each other. They are electrically connected. They're continuous, right? And these holes are continuous with each other. So they are in groups of 5. These 5 holes are not connected to these 5 holes at all, or to these 5 holes, or anything like that. They're just connected in lines like this. Okay. Now that's in contrast to these groups of 5. These groups of 5 are continuously connected. All these groups of 5. For example, the 4 groups of 5 you see here, they're connected, right? But these are not like that. These are not connected to these. Okay, you get the idea, right? So what does that mean? That means if you have a component like, let's say, this capacitor, you know, it has these prongs. You can insert those prongs into some of these holes if you could fit them, all right? Okay, so I have fit those prongs into some holes. Let me verify which holes I have fit them into. So here I have gone into holes of row 44 and row 42. All right, it's hard to see in the movie, but there are these little numbers printed on here, and I have gone into the holes of row 42 and the holes of row 44. What does that mean? That means I can now power this capacitor. Okay, so this is the negative side is on this side, and that's in hole 44. So I can put a little wire in hole 44, and I can power the capacitor with 5 volts by putting the negative side of the capacitor into a ground hole, any one of those ground holes, and I can put the positive side of the capacitor using another wire. Let me just use this wire because it's handy. That other pin of the capacitor was in hole 42. All right. So now I can put the positive side of the capacitor onto the positive 5 rail. So now I am powering up this capacitor. I'm charging up the capacitor. So you can't see the capacitor being charged up. So how do you know that this is happening? You can know that this is happening by using a multimeter. Okay? But I can make you a separate video for that. And you can put other things on this board. You can put LEDs on this board, or you can even put Christmas lights if you find that the wires are long enough to fit into these holes. I'm not sure that they would be, but I would recommend LEDs. You could put wire leads to electric motors and have things spin around on this board. So that's how to use this board. It's much more convenient than using batteries because batteries fail. But here, you know, if something bad happens in the circuit, i.e. it doesn't do what you want it to do, you know that it's not a power issue because the power is reliable. You plug this into your wall. It's not the battery that died. And this is also nice because you don't have to go buy batteries every time your kids put the positive ends to the negative ends and short circuit all the batteries to make them get hot and then die. So this is a very convenient tool for physics. I'm not sure about the standards for first year physics, but for AP Physics, especially for AP Physics 2 or AP Physics C, electricity and magnetism, this is cool.